So, Assalamu alaikum everyone. My name is Gulrasta and I'm the first year student of bachelor's degree in Tashkent State University of Economics. My faculty is business administration and now I'm going to show you the economy of Romania and how to do research on it according to data. So, first of all, I'm going to show you the steps of doing this research looking into my plan. So here is my plan and there is 18 categories in that, and I will show you step by step how to do my research. First of all, I will open data profile in World Bank Open Data, and I will search my country and download Excel file from it. For doing this, first of all, I will enter to Google and write down World Bank Open Data. And you can see this page and browse by country. My country's name is Romania. I will enter to this, and you can see there is 3 types of files in here, and I will choose Excel file. So here it is, it's downloading and I will open it. After opening it, there will appear these 3 categories, and you should enter to data category. And now I'm going to choose the categories that I want to do on my data research. So I will color them in red. So here I have chosen my indicators, variables from here. The first one is years, you can see there, years, and then my variables, this one. So there are 3 variables that I have chosen, and now I should copy them in another new list. For this, I will open new list from here and start copying all of my variables from here and paste them in the new list. For copying them, I will enter copy and then go to the new list and enter the 4th category. So now you can see it will be pasted like this. So I will continue with other variables. After here, I should choose my dependent variable from here. So here is my dependent variable, and I also do this. I will continue like this. Oh. Second one. And the last one. So it is the last one. So here I have pasted all of my variables into the new list, and I should delete these columns from here. They are not necessary for us. What's happening? So it's ready, and I will color them in black. And the next step that I should do is changing the indicator names. For example, I will change this variable into year, and I should say that you shouldn't left space between your words, because Stata cannot read the words that have spaces between words. So for this, I will write them without spaces. Urban population grows. And so all of them are ready now, and you can see, and there is all of my variables. And if I so in the bottom there are also other variables that are typed with them. So for reading, for Stata being able to read this information, I should only select the first one from here and paste it in the other list. So I select it, Control C and Control V. So I have pasted it. So it's ready now, and I have downloaded my Excel file from here, and I will save it. So it is saved. So the first step is done, and I will put plus on my plan. So I just have finished the first task, and it's time to do the second task, which is importing Excel file into Stata and saving it as the tab file. So for this, first of all, I will open the Stata from my files, and it's in here. So you can see I have opened it as Stata, and I will start by giving the command of log begin. And now every time if you start doing research in Stata, you should put a name into your log file. For example, I can put name, you can put any name for it. So, and don't forget to press the second button, which is log, and save it. Now you can see I have created a log file from a name like this, and I will start by importing Excel file. I will browse from here, and I have already prepared Excel file, downloaded it from World Bank Open Data, so I can enter it. Now you can see there is a period, and don't forget to tick this column, and okay. Now you can see there appeared variables here, and for checking the state of them I will give the command of browse, which is in short way BR. So now you can see here variable is incorrect because it's in red color, and I will change it and correct it from Stata. For it, I will open the data, create or change data, this one, and then I will press this button. In here, you should write the incorrect variable. For example, mine is year, and now in here I will write down the correct way, years. Okay. So now you can see the period years variable, new variable, and I will browse it for checking. Now you can see there is years variable, and it's in black color, which means it's not mistake. And now I should delete this variable. For this, there are two ways. The first way is to choose drop selected variables option, or the second way is writing down drop and the name of variable from here and enter. So you can see our variable is disappeared, and now it's time to save it as the tab file. For it, I will press this button, and here you can save it as the tab file and put a name for it. For example, I can give the name, and it will be saved as the tab file. So you can see it is saved as the tab file into my documents. And now I will start, and it's time to creating do file. For creating do file, you should enter this option. You can see new do file editor, and you can write down the commands. For example, I have done log begin command, and then browse, and and then drop variable, for example. So by writing down your commands, you can create your own do file, and I have already created my do file, so there is no need to save it. But if you want to save, you can press the button save, and you can see it will be saved as do file into your documents. As I said, my do file is already created, so I don't save it into my documents. So I will cancel. Now I will put plus. I have done the second task, and put plus. I have done the process of making do and log file, so I can put plus on it. And it's time to do analysis, and saving your results into your research paper. So first of all, I will start by opening my do file, and it's my do file. So as you can see, it's the comments that I have created already, and I will start giving them step by step. First of all, I have already do the command of log begin, browse, and this command is for people who are new and doing the Stata using Stata program first time. If you are new, you can give this command into your Stata, and by giving this command there will be connection between your laptop and a Stata program. So I have already used this program a lot of, so there is no need to giving this command. And I will start by giving the command of summarization. Execute. And if you want the file of your commands, you can write down as doc before it, so there will be appeared the file of your commands. For example, this table will be appeared in this document. As you can see, as I have already done a lot of Stata research, there appeared a lot of them, and every time if you give the command as doc, your table or your pictures will be appeared in the last paper. Every new tables will be appeared in the last paper, and it is my table, and I should copy and save it into my research paper, but I have done it already and saved it into my document and already, and I will show you it. For example, you can paste. First of all, I will copy. Now I can paste it into my research paper. So you can see it and correct it in any way you want. So every time if there is appeared pictures or files, you should save them into your document, because if you restart your Stata, all the comments and pictures will be disappeared, and your work will be deleted from everywhere. So don't forget to save every command you have done in Stata research. And I will start by creating graphs, and it's our first graph. Now you can see the graph, and it's called scatter plot. It always the scatter plot always illustrates the relationship between dependent variable and independent variables. For example, in this picture there is the relationship between electric power consumption, which is dependent variable, and independent variable urban population grows. For example, when the value of dependent variable reaches 5,200, the urban population grows, shows the value of approximately 6 or no, maybe for example 0.6, I think. So it's the relationship between them. This, and I have forgotten to explain this graph. So here you can see this table describes the summary of Romanian country's 3 variables data. In the first column, you can see there is given the names of variables, which are years, electric power consumption, urban population growth, and GDP energy use. And the second column describes the duration of observation of each variable. For example, the observation number of years is 36, electric power consumption is 25, and so on. And the next one is called mean, and it describes the average point of variables. If we look at GDP energy use, it had been over 5 points in Romania. So the next one is standard deviation. So standard deviation gives information of variables, how they are far or close to the mean point. Standard deviation value of, for example, electric power consumption is over 3000, while years is 18 over 18. And the last 2 columns describe the minimum and maximum point of these variables. For example, minimum year is 1960 and maximum year is 2022. And I have done this command already, and these other commands are also the same as the first one, and they are describing another variables with them. For example, I will show it from my research paper. It's the relationship between electric power consumption and urban population growth, and this one is GDP energy use and dependent variable, and this one is the year with dependent variable. And the next command is, so we should give this command because it can describe our data is time series. If we don't give this command, it will be cross-sectional data for us. And I will start by giving this command. As you can see, it's the line graph, and this line graph illustrates the amount of electric power consumption in Romania between 1995 approximately and 2022. It's clear that until 1998 there had been a considerable decrease in the amount of power consumption. From 5,000 kilowatt to approximately 4,600, but it has been overshadowed by the sharp increase from the year 2000 and 2008. After that, there has happened fluctuation in the amount of electric power consumption until 2019. So every line graph will be described like this, and these are the comments that I have already given, and these are the pictures of them. I will save them into my research paper, and these are the combination of them. And the next comment is a scatter plot of 2 variables, and the fitted values you can see here. Execute. So you can see it's also like the first picture, but there is the fitted values which describes the relationship between two variables are positive or negative. And in this picture you can see the relationship among electric power consumption and urban population growth, and this can be seen that there is a positive relationship because fitted values is increasing by the time. And other scatter plots will be like this. For example, you can see it from here. I have saved them, and these are the combination of them. You can see it's urban population growth and dependent variable relationship, and this is the relationship between year and the urban population growth, and so on. And the next comment. And the next comment is Pearson and Spearman correlation coefficient. So I will start by giving this comment. So you can see my file doc couldn't be opened. This kind of comment will be appeared if you do not exit from my file doc. And now if we give this comment, it will be appeared. So you can see. So every time you open another my file, you should exit from the letter my file. Here you can see it is the Pearson correlation between the variables, and you can see 1 unit increase in electric power consumption causes increase in all variables. For example, 83% in years, 74% in urban population growth, and 80% in GDP energy use. All variables have significant correlation because of the p-value. As you can see, p-value should be lower than 0.005, which is 5%. So all variables here are significant correlation. And the next one is Spearman correlation. You can see. So it's the Spearman correlation, but it also looks like to Pearson correlation, but the difference between them is that Pearson and Spearman correlation coefficients are two widely used statistical measures when measuring the relationship between variables. And the difference between them is that the Pearson correlation coefficient assesses the linear relationship, and the Spearman correlation evaluates the monadic relationship between variables. So as you can see, Spearman correlation, you can see that 1 unit increase in years leads to for example in here 1 unit increase in years leads to over 40% and 100% growth in urban population growth and GDP energy use respectively. So the another comment is p-norm. So as you can see, it's the p-norm. It evaluates how far our graphs are far from the mean, which is the average point. And these are p-norm graphs that I have created already. This one, and these are combinations of them. And the next comment is checking on the key density. So here you can see it's called histogram. Histogram in this picture illustrates the information about the distribution of dataset. Every shape of histogram should be bell-shaped. In this histogram, bins are the same in the year variable, and you can see this line should be bell-shaped. It means that the line should be somehow similar to this line, like bell shape, but our line is not bell shaped, and it means that the dataset is not normally distributed in this histogram. And you can see it's also not bell shaped. And also this data is not normally distributed, but in urban population growth histogram, the dataset is somehow is normally distributed, because as you can see it is like the bell-shaped, and this one is not also bell-shaped. These are the combination of histograms that I have created by giving the comments, these comments. And now it's time to show graph box. I can, for example, choose this one and execute. You can see it's the graph box. In any graph box, the square shape always describes the 70% of data, and this is called the median, which locates inside the box, and it means the mean of research variables. Two lines that span from the first quartile give 25% of information. And if I explain this picture, the mean of graph box is 0.6 approximately, and the minimum point is over 0 and maximum point is over 2. You can see the exact data of minimum and maximum and mean points from the first command that I have given. For example, it's in here. So you can see that urban population growth mean is 0.968, minimum point is over 0, and maximum point is over 2. And it's the same in this picture. As you can see, it's the picture of the data, and it is the table of the data. And other comments will be also like these comments, and I will show them from my research paper. Here is a combination of graph box. And the next command is Shapiro-Wilk test. Execute. So I will check that I have exited my file. So I have exited my file. Now you can see it from here. So, Shapiro-Wilk test checks if a statistical test used to assess whether a dataset follows a normal distribution. For example, the value of W ranges from between 0 and 1. In our result, all of our variables are normally distributed because they are very close to 1, and in this table of our p-values are significant except electric power consumption, because p-values need to be lower than 0.005, which is 5%. And our next command is regression. Execute. So it's also like this because I have not exited from my file doc. Where's that? This one. And it's not necessary for us. I will explain it from this data itself. So, linear regression represents the linear relationship between dependent and independent variables. For example, electric power consumption is dependent variable, and these are independent variables here. In this regression, observation number is 25, you can see. F-test assess the overall significance of linear regression. In our regression, F-test equals to 36, and the probability of the F-test is 0, which means the relationship between dependent and independent variables is significant. And R squared means that our relationship, our 90% dependent variable, which is electric power consumption, is expressed by independent variables, while the rest of dependent variable expressed by 10% of it expressed by other factors. And coming to the coefficient part, you can see there, it describes that 1 unit increase in the year has a positive effect with over 52 points in electric power consumption, and 1 unit decrease in GDP with over 57% independent variable electric power consumption. It has a negative effect. And standard error quantifies the variability or uncertainty associated with the estimated coefficient. For example, standard error in GDP energy use category is equal to over 21, which demonstrates the fact that there are so many errors in the analysis part. So the next one is t-test, or the student test, describes that every independent variable has its H0 hypothesis. This test also has a p-value that needs to be lower than 0.005. When the p-value of the test is lower than 5%, that means the variable is significant. But in this test, every independent variable is significant except GDP energy use, because it's not lower than 5%. And in this variable, we should reject the H0 hypothesis and accept the H1 hypothesis. And the next comment. Next command is robust regression. Execute. So you can see it here. So robust linear regression is designed to be more resistant to the influence of outliers and deviations from assumptions compared to traditional linear regression. For example, in standard error category, the values differs. I will show it now. You can see. So, to example, years variable is over 9 in standard error category in traditional linear regression, but in robust regression it shows that it is nearly 9, and it's the difference between these two types of regressions. The next command is here it is. Oh no. So now I will continue with the next command. Next command is our next command is checking the reliability of the model, which is reliability Cron-Batch alpha test. So executing. You can see it from here, and I will open it from my file doc. So here it is. The alpha test assesses the significance of the relationship between the independent variables in regression analysis. So the coefficient is 0.0942, which indicates the statistical significance of our regression analysis. And the next one, I will exit from my file doc. Next command is multicollinear test. So here you can see it, VIF. So this variance, this is called variance inflation factors for independent variables, which is the indicator of problem of collinearity in analysis. VIF value should be lower than 10. If it's lower than 10, that indicates that you don't have problem with collinearity. But in our VIF value, all variables are lower than 10 except years, which describes over 11 point. So this means that our analysis has a few problems with collinearity. And so this is the end of our commands, and now I can finish my video. So now I will put plus on my tasks, and I have finished analysis, so I will put a plus on it.